Linear momentum is defined as the product of a moving object's mass and its velocity. It is a measure of its moving inertia. What does this mean? Well, everyday experience tells us that the more massive an object is, the more difficult it is to change its state of motion. Of the three cars in the image, which all have the same velocity, the most difficult to stop is the one with the highest mass. And the same happens with the velocity. For which of these three cars is it easiest to change its motion? As we know, a change in an object's state of motion implies there is acceleration. And acceleration is the change of velocity over time. Therefore, we can express the change of linear momentum over time in this way. Does this look familiar? Yes. According to Newton's second law, this is the force applied on the object. Thus, we can also define the force as the change of linear momentum of an object over time. The study of momentum yields one of the most important conservation laws in physics. Consider, for example, two bodies that collide, like two bumper cars. Newton's third law tells us that the forces exerted by each car on the other car are equal and opposite. In terms of momentum, this means that the change of linear momentum of one car is equal and opposite to the change of linear momentum of the other car. That is, the difference between the initial and final momentum of one car is the same, in magnitude, to that of the other car, and opposite in sign. Rearranging this expression, we conclude that the total initial momentum of the system is equal to the total final momentum. In other words, the total momentum of the system is conserved. There are two main types of collisions. In an elastic collision, the shapes of the colliding objects remain unchanged and do not stick together afterwards. Both linear momentum and energy are conserved. A common example is that of two pool balls colliding on a pool table. In this case, we can write the conservation of linear momentum in terms of the masses and velocities of the objects in this way. On the other hand, during inelastic collisions, objects change form on impact and they can stick together afterwards. Some of the energy of the system is lost, but still, the total linear momentum is conserved. If the two objects stick together after the collision, we can write the conservation of linear momentum in terms of the masses and velocities of the objects like this.